Okay, class, this podcast has to do with acid and base properties. So, we're familiar with quite a few acids. Some of these acids we eat. Vinegar is an acid, it's acetic acid, so it is just acetate ion with an H. And usually acids get a bad kind of rap, and bases we don't talk about a whole lot, but bases are really just as dangerous as acids. Some of them more so than acids. But what we're going to do is we're going to learn the Arrhenius definition of acids and bases. There's several different ways we can define acids and bases, and this is probably the simplest. So Arrhenius is just a guy's name, and he was just a scientist that did work on acids and bases, I think back in the 1800s, maybe 1700s. But his definition of acids is simply anything that produces hydronium ion. Okay, and hydronium we have not seen before, but it's a good name to know. Hydronium ion in water. And hydronium ion is just H3O with a positive 1 charge. Okay, so this is hydronium. It's something that you should definitely know. And essentially, all this is if we have an H plus ion, so just a hydrogen ion, and we add it to water, we really haven't talked about balanced equations or equations yet, but things on the left side of the equation are reactants. So if we take a hydrogen and react it with water, we produce, and products are written on the right, we produce hydronium. Okay? So the simplest thing is all acids have to have an H, because you have to have an H to get the hydronium. So all acids begin with hydrogen. So I'm just going to do some examples. HCl is hydrochloric acid. H2SO4 is sulfuric acid. H2CO3 is carbonic acid. And HCl is the stomach acid. It's in our stomachs. Sulfuric acid is battery acid. And carbonic acid is like acid that's in sodas. It makes them carbonated. Okay? So that is the Arrhenius definition for acids. And similarly, the Arrhenius definition for bases is going to be pretty similar. We're just going to copy most of this. I'm just going to do little like caret marks. So we're going to say anything that produces hydroxide ions. Alright, and hydroxide is one of our polyatomic ions. So it is one you should be familiar with, and it is simply OH minus. Okay? So bases are anything that have an OH with them, metals with an OH. So some common ones, or ones that we'll see in class quite often, are sodium hydroxide, we might have lithium hydroxide, or possibly potassium hydroxide. And then we can have other ones, magnesium hydroxide, calcium hydroxide, but ones we typically do are alkali metals with hydroxide. Okay? And that's acids and bases. Some properties that they have are going to be acids obviously produce hydronium, and acids typically taste sour. Alright, so another acid we're familiar with is citric acid, and it's in citrus fruits. So oranges and lemons and limes, all those have citric acid, and that tastes very sour. Bases, on the other hand, typically taste bitter. A good example is sodium bicarbonate. It is baking soda, if you've ever tasted that. It's very, I don't know, if you like bitter stuff, you'll like it, but it is very nasty on your tongue because it has a very bitter taste. The other thing we might say is bases are often slippery. They feel slippery. And the other place we have bases is typically in soaps. They typically have bases in them, and that's why when you lather up, you're very slippery, because you're really putting bases all over your body. Okay? And what else? I think that's really the properties I want you to know. So Arrhenius definition, no base, Arrhenius base definition. And then the last thing we're going to do is we're going to talk about pH. And pH is a way that we can measure how strong an acid is or how strong a base is. And it's a scale that ranges from 1 to 14. Alright? And it is simply just a scale. And again, it's from the value 1 to 14. Right in the middle, obviously, would be a 7. And something that has a pH of 7 is considered neutral. Okay? And that means it's neither acidic nor basic. So we really have equal parts hydronium and equal parts hydroxide. And the interesting thing is, if we add these two things together, we get a formula. I'm going to do that right over here. I'm going to change my ink color. If we add H3O plus and we add OH minus, we get 2 waters. So if we have pure water, it has a pH of 7. It's neither acidic nor basic. Most of the time water, just because there's carbon dioxide in the air, a little bit of it dissolves in the water, and most water, like out of the tap, is usually going to be somewhere in the 6.5 to 6.7 range. Okay, is typically what water is. But if we have pure water, distilled water, deionized water, it should have a pH of 7. Okay? And then the next thing I want you to know is, if it is less than 7, okay, it is going to be considered acidic. 1 would be really, really acidic, and as we leave 1 get closer to 7, it becomes less and less acidic. And then conversely, if it's greater than 7, so between 7 and 14, it is considered basic. If it has a pH of 14, it's really basic. It is dangerous, just like something with a pH of 1 would be dangerous on the acid side. And as it gets closer to 7, it becomes less basic. Okay? And it's just a continuum. 7 is completely neutral. Less than 7 is acidic. Greater than 7 is basic. And pH meters are typically probes, and you'll be using them in the lab a couple times. But it's just, you set it in the liquid, and it gives you a pH reading, and you know how acidic or basic something is.